Yeah, good evening, everyone. Switch on again. Let's start off. Others need to keep your cams on.
Face wash and put it in.
Yeah. So last class we have just finished this introduction of the three equations. So let's start with the problem. So the three equations, I'm sure you know this stuff. So let's start off with something easy and then we'll go ahead. We have a vehicle here going with a constant acceleration. Let's say the speed at A is 20 kilometers per hour. The speed at C is 30 kilometers per hour. This is point B. And we have AB is to BC is in the ratio of 2:3. So a vehicle is moving with constant acceleration from A to C. Around 30 kilometers per hour at B. Find the speed at B. Let's get this. Today we'll have little less of calculus. So mostly we'll be solving mostly uniform acceleration motion. So the three equations will be played around with more of that. Dikshita, do keep your cam on. (10√6). Okay, we have one answer. We have one answer so far. Everyone others try. Right, Lakshika, Hanika. Others. Dikshita, are you there? Yeah. Do adjust your cams, everyone. Make sure your face is completely visible on the screen. Dikshita, I can't see you. Anshul, I can't see you. Ekansh, I can't see you. How do we do this? So you said this is the ratio of 2:3. So let this be 2s. Let this be 3s. And let the speed here be VB. Now, if you look at this, the end of the day, we have to use the three equations. The first equation is V is U plus AT. The third is S is UT plus half AT square. And the third is V square minus U square is 2S. If you observe one thing in this, there is no mention of time anywhere. So that should give you a hint that you have to use the third equation. So when you go from A to B is final, whereas A is initial. That would be 2A to S. And when you go from B to C, VC square minus VB square will be 2A 3S. Equation 1 and equation 2. Divide them. You end up with VB square minus VA square by VC square minus VB square will be in the ratio of 2:3. So 2VB square minus 3VA square is equal to 2VC square minus 2VB square. So from here we end up with VB is equal to 3VA square plus 2VC square by 5 or 4.
Sir, 3VB square.
Yeah, 5. Curve root. That's your answer. You can substitute the values now. Do check this out. So what we did is simply we use the third equation, V square minus U square is equal to 2S for two parts, from A to B and B to C. And then we just finished it. So from when you go from A to B, B is final and A is initial. When you go from B to C, B is initial and C is final. Dikshita, you need to adjust your camera a bit more. Dikshita, are you there? Can you hear me?
Yes, sir.
Do adjust your camera a little bit more. I can't see you actually. So if I ask you something, you can nod also. I can see you on the screen. So
Okay, so just
all clear with this? Easy? Simple one. Let's see something a little more weird. Any doubts on this thing? Sarja, clear? Siddharth, Ekansh, Ali? Ali, where are you? Ali is
The final answer is 10 root 6.
yeah, 10 root 6. Next one. We have two trains, A and B, on a parallel track, starting from rest. Both the trains accelerate with A1 and A2 for time t. And then the acceleration becomes A2 and A1. The acceleration is reverse. Two trains A and B on parallel tracks. Start from rest. Moving with acceleration A1 and A2. For time t. Then acceleration becomes A2 and A1 So acceleration basically becomes reversed. They interchange accelerations for another time t. Find the ratio of distance traveled in 2t that is SA by SB. Find the range of SA by SB. So you get SA SB ka ratio. What is the maximum and the minimum value of that ratio? That's the meaning of range. I hope the question was clear. We have two trains, both are starting from the same place. A has acceleration A1. If I give you numbers, right, it will be like this. Train A has acceleration 1 meter per second square, B has 2 meter per second square. After 1 hour, A starts accelerating with 2 meter per second square and B starts accelerating 1 meter per second square for another 1 hour. So total journey is 2 hours. So initially A is going with A1 for time t, then A2 for time t. B is going with A2 and then A1. Find the ratio of distance traveled SA by SB and find the maximum and the minimum value of SA by SB. There's no calculus, nothing. Today we will not have much of nothing over calculus. Next class we'll have proper calculus problems again. Today it will be little on the easier side. So let's see. Since we said uniform acceleration motion, we can't bring this thing. Ali, focus on this problem right now. Ali, focus on this problem. Right, you missed it, right? You'll get the notes end of the session. You can have a look at them. If I show you the previous problem, you won't do this. Let's not waste our time. Let's get this. Anyone who didn't get the question, please ask me. Remember this, if you don't understand the question, it is my fault. You don't know how to do, that is okay. We will do it together. Give it a try. You got 2-3 minutes. Question should be always clear. What am I asking? What is happening? Think about it. Take a minute. Mahalakshika, that is right. Try. How do you find the range? One, that's a trap. Anika, you could have simplified it, you could have just divided it by 2, Anika. You are right though. Ekansh, you are right. Pratyush, you got it right. Anna, you are wrong. Ekansh, why did you have two different answers? Ekansh, you're wrong anyway. That is wrong. Both are wrong. Siddharth, you are right. Aryan answers. Dikshita answers. Anshul. Others, do type your answers here to the co-host. There are two of my accounts. One is the host where I'm writing. I won't be able to see anything there. The other one is my laptop where I'm actually seeing you guys on a screen. You have to type to the co-host. People who got the answer, find the second part. What is the range of this thing? What is the maximum value and the minimum value of this function? Others who don't get C, why you have not got? Anna, it is not 1. See where it went wrong. A1 by A2, no Aryan, that's not the answer. Mayuka, answers? Dikshita, any answer? Raja, answers? Ali, both of you, no answers so far. Show you? See, always when you solve, right, have a small diagram, one of the mistake you guys do, what? You guys don't draw a diagram. You guys think you can just, think in the air and get the answers. Don't do that. Physics doesn't work that way. Make it a habit of drawing a small diagram for your understanding. When you can't draw a diagram, means you didn't understand the question. So if you draw the diagram here, this is how it looks for A. So A is here. You observe every question that I do, I always try to put a diagram, even though it might not look necessary, important. Trust me on that. It helps you a lot. It helps you to visualize stuff more easily. Exam may actually get speed. The more you do well in practice systematically, the faster you can be in the exam. So when you go from here to here, what's the distance traveled? We are using the formula S is equal to ut plus half at square. The initial speed is 0. So this would be half a1 t square. Now, the mistake you guys are doing is people who got 1:1. Will the train A come to rest here? Train A will have maximum speed here, a1t. And now your acceleration has become a2. So for the second part of the motion, this will travel S is equal to ut, that is a1t into t plus half a2t square. So the total distance traveled by A will be half a1 t square plus a1 t square plus a2 t square. 3 by 2 a1 t square plus a2 by 2 t square. Please check. So after the first time t gets over, the train has gained some speed. So the second half of the motion, the initial speed is not 0. No, that's a mistake you did. That's the reason you got 1:1. If you do the same thing for train B, your initial speed is 0 and your acceleration is a2. The train B reaches here. This distance will be ut plus half at square. That will be half a2 t square. You must have gained a speed of a2 t. Now your distance travel will be initial speed is a2 t into t plus half a1. Now your acceleration has become a1 t square. So the total distance traveled by B will be half a2. So this will be 3 a2 by 2 t square plus a1 by 2 t square. So if you take the ratio SA by SB, t square will cancel. You end up with 3a1 plus a2 by 3a2 plus a1. Please check. No, Siddharth, that's not the answer. Do have a look at this, everyone.
Is my final limit correct?
That is not the answer. Right? So don't try to bargain for answers there. Final limit, lower limit, exam you'll get a -1 for that. Either you got it right or not, didn't get anything. That's it. Think. Get me the full answer. Aryan, got this? What I did? Make sense? Dikshita, sure with this?
Yes.
Clear, na? Ali? Abdi Ali, clear? Others, Ane, got the mistake? Mayuka, clear? Lakshika didn't get the ratio. Pratyush, got the ratio? No. So what to do for the ratio part? Any doubts on this page? Please ask me. Can I turn the page? Sharja, clear, na? Got this? Ekang, didn't get the ratio. See, how to get the ratio there? Can I turn the page, Dikshita? Yeah. So we got the ratio here, SA by SB 3a1 plus a2 by a1 plus 3a2. I just reversed it. So whenever you want ratios, right, you take a range. So what is the answer, Ekansh, then? If you got it, the range ka ratio, second part of the answer, not the first part. So this is what we do. If a1 is much greater than 2, that symbol is much greater than. So I can write this thing as SA by SB is equal to, take out A2 common, A1 common, you get 3 plus A2 by A1 by 1 plus 3 A2 by A1. If A1 is much greater than A2, that means A2 by A1 will tend to 0. Right, Ekansh? Are you getting it? If you take the acceleration of one train is very large, so let's say 1000 meter per second square, another train is only like 0.1 meter per second square, then this term will tend to 0 and this term will tend to 0. This thing approximately turns out to be 3. Similarly, if you take A1 is much less than A2, the reverse, this time we get A1 by A2 will tend to 0. Then we get SA by SB. You can just modify this as A1 by A2 plus A1 by 3 plus A1 by A2. This time will be 0 and this term will be 0. This thing will be approximately 1 by 3. So you will never reach 3 and 1 by 3. So SA by SB, the value will always lie between 3 and 1 by 3. You can't exceed this. No matter whatever is the acceleration, the value should always lie between 1 by 3 and 3. So whenever they ask you for a range, you have to see the extreme possibilities. So in this case, the extreme possibilities is one guy is having an infinite acceleration, the other guy is almost having negligible acceleration. That's how you handle this thing. Do check it out. And if you observe one thing, I didn't give a single number in the question. A1, A2, everything, and I still got a number in the answer. This will be an integer question in integer type question. Find the maximum value of SA by SB. That is how a question can be framed. Do have a look at this. Ask me if you're confused. Clear? Siddharth, got this thing? You got the upper
Yes,
range.
so but what if both, like, we can't take both accelerations if they were supposed to be 0? Like, is that
Well,
possible?
you are saying both will tend. 0 means they won't even start now, right, Siddharth?
But no, we can't take that as a hypothetical situation.
Then you get 0 by 0. What is the value of 0 by 0? You know that.
Okay, fine.
Then,
Infinity will take it.
and the fine Thabo. Clear, everyone? Easy? Make sense? The first part is manageable. Second one is a little different. Going ahead. Next one. Ali, clear, na? Can I go ahead? Ali, clear, na? Next one. Let's do a little easier one. We have a vehicle here. Starting with an acceleration A and U. Find the ratio of distance traveled in n seconds and nth second. Both are two different things. Huh? That one word will mess up everything. Example, if I say 3 seconds, the meaning is 0 to 3. If I say third second, means 2 to 3. For example, see 0 to 1 is called first second. 1 to 2 is called second second. 2 to 3 is called third second.
So there is a formula for n and second, n plus
So,
1 something.
do you know the formula? Derive. Derive.
n plus 1 or n minus 1.
Abhi why guy hai na Ali, but this is what you'll do in the exam na. 1 plus n plus you'll get a -1 and come solve.
Sir, I have not studied kinematics for last 2 days.
So
Like,
so what? So what? You'll get a -1. Derive. What is the guarantee you'll remember in the exam? You should know how to solve. We have a
I
vehicle
don't know how
starting
to
with
derive only.
So think na Ali. That's why I'm giving you 2-3 minutes to think, right? Where am I asking you to get the answer? If you're not getting, I'm there to help you. But first, I need you to help yourself. Help yourself first, and then ask for help. Try. Exam I can't come na. I can't come near the window and throw chittis from the window, right? That would be interesting, but not possible.
तो काश ऐसा हो सकता.
काश क्या होता है? I'll do for physics, maths, chemistry क्या करोगे?
So
In front of your
दूसरे टीचर को बुला लेंगे.
हाँ, और कुछ काम नहीं है. In front of the window, teachers will be hanging like bats. करो solve कर. वो better है. Instead of making teachers run around the center with chittis and throwing everywhere. चलो at least you said chittis. Teacher का brain खा लेते हैं हम. Best है. We have 2 answers. Try others. You got a minute. And I hope everyone got the meaning of n seconds and nth second. Both are not the same. हाँ Dikshita, that is clear, right? N seconds and nth second का meaning. Yeah. Right, Pratyush. Maika, answers. Aryan, Anai, Sarja, answers. Didn't have any answers today, Sarja. Yeah, answer comes in terms of UA and Anika. Obvious. I gave you nothing else there. So n seconds, you're starting here. Speed is u, acceleration is a. So Sn will be u into n plus half into a into n square, straightforward. But if you take for t is equal to n minus 1, then Sn minus 1 will be u into n minus 1 plus half into n minus 1 whole square. So you want nth second, subtract them. The nth second will be distance up to n, distance up to n minus 1. This would be your nth second. So just subtract them. You end up with un plus half a n square minus un minus u plus half a n square minus plus a by 2 minus a n. Half a n square un, half a n square un cancels off. You get u plus a minus goes inside. So u plus n minus half. This is your nth second, everyone. That's a general formula. You can just divide them. So you want to answer Sn by Snth. This is the nth second ka distance. This is n seconds ka distance. Clear? Easy?
So the value that you got, that is Sn is equal to u plus a into n minus half, is also the general formula to find the time
For
in
the nth
distance.
distance. Yeah. For the nth second ka distance. Clear, everyone? Easy? Next one. Ali, clear na? Let's see one more easy one. We have a vehicle here whose speed is 10 meter per second. Acceleration is backward 2 meter per second square. Find distance traveled in 15 seconds. All these are standard problems. So like I said, we need to learn the standard problems also. Because mains and bits are standard problems. Advanced may half of the paper will still be some standard problems. The remaining half will be something weird. So we will do a balance of everything. Get this thing. Easy one, but a good one. And I told you multiple times, when you hear the word distance, be scared. Be little careful. Try, you got 2 minutes. We have a vehicle whose velocity is forward but acceleration is backward. Find the distance traveled in 15 seconds. Right, Egan. Lakshika, both of you got it. Right, Ali. What is the catch here? Remember, we did a problem like this before, finding distances. Always find the point when it stops. So if you look at the motion of this thing, this is how it goes actually. At t0, you're here, it goes forward, takes a turn and comes back. So at this point, your velocity is 0. So using the formula v square minus u square is 2as. V would be 0, u is 10 square. 2, acceleration is minus 2, right positive, left negative. This is s. We end up with s is equal to 25 meters, meaning you travel 25 meters forward and then you stop. Now, if I use the formula directly for 15 seconds, s is ut plus half at square. At t is equal to 15, we get, most people do this thing. They substitute this formula directly. Half a is minus 2 because it is backward. You end up with minus 75 meters. Remember, this s is displacement. This is not distance traveled. 75 will be there in the option. And most people will mark it without seeing. What is the meaning of this minus 75? At t is equal to 15 seconds, you have reached at x is equal to minus 75. Now you think about it logically. You started from x is equal to 0. You went to x is equal to 25. Then you came to x is equal to minus 75. So how much did you travel? You went 25 meters forward and then you went 100 meters backward. So distance would be the length of the path traveled. That will be 25 forward, 25 back to the origin, and 75 from the origin, 125 meters. Please check. Whenever they ask you to find the distance, you literally have to draw the path. There is no direct formula for distance in physics, until unless there's an integration problem. Normally, you have to draw the path and see how is it actually traveling. This guy is going front and then coming back. If you use ut plus half at square, what you get is displacement. So think logically, at x0, t0, you're at x0. Suddenly you appeared at 25 and suddenly you appeared at minus 75. Minus 75 indicates you're 75 meters behind from the starting position. Right, Arjun? Easy? All got this? So be careful. It's not a tough question, but what happens, exam when the first option is 75 meters, you see that and you think it is right. And by the way, I forgot that this week test is online. Huh? This week test is online on basic maths and vectors. Dikshita, you need to register. So just ping me in WhatsApp, okay? I'll send you the testing site ka link. You can register, I'll give you the access. Okay. So the deadline will be there till Tuesday. So make sure to give the paper, right?
Okay.
Yeah. So everyone, you need to give the paper
The
before
calculus
Tuesday.
also, no?
Basic maths, calculus, and vectors. Okay. Next week we'll have a test on 1D. So every week you'll have a test of 1 hour where the paper I'll keep it open for like 5 days, 4 to 5 days. So every week you'll have a test. So that will keep you on track with whatever is happening. And the result will be posted on Wednesday or something, and the new paper will be online on Thursday. So this is the cycle. Clear? Let's see something little weird. Not really weird, but it's a good one. Like I said, there is very not too much that I can ask you in uniform. Once we go to vertical, it will be more fun. So we have a train here. That's a siren kind of thing. So we have a point. So we have a person here. Let's say the train ka acceleration A is equal to 2 meters per second square. So this is position A, this is position B, and this is position C. So this line BC is perpendicular to the railway track. And this distance is 400 meters. And B to C is 300 meters. So this is the scenario there. So initially the train is starting from rest. A train starting from rest sounds a horn. So train ka there'll be a siren, it blows a siren. Starting from rest with acceleration A is equal to 2 meters per second square. It sounds a horn from A to B. So as the train is starting for the first 400 meters, it will be making a sound, whatever is the sound it makes. It makes a sound a horn from A to B. Okay. And a person is standing. A person stands at C, right? And the B to C length is 300 meters and BC is perpendicular. Person standing at C hears the sound. Person stands at C. The speed of sound is 300 meters per second. Actually, speed of sound is 330, but for calculation, we'll keep it 300. So the question is, it sounds a horn from A to B. Matlab after reaching B, the horn will stop. For how long did the person at point C hear the sound? Again, listen to this question. We have a train which is starting from point A, acceleration is 2 meters per second square, distance is 400 meters from A to B. So when the engine starts, it makes a sound, whatever it is, from A to B for till you reach B. Once you reach B, the siren stops. There's a person standing at a distance of 300 meters from the track, perpendicular BC. So this person is just standing there and listening to the siren. So the question is, for how long did this person hear the sound? Think about this. It's a pretty good question. 21, Rakshika. That is wrong. What you did was something else. The question is, how long did he hear the siren? No, Anay. That's not the answer. 20 is not the answer. That is the best part. If the siren is on for 1 minute, he actually hears less than 1 minute. Think about it. Think. You got 3-4 minutes. This will be a proper advanced question. It's like I am speaking to you for 10 seconds, but you actually hear my voice for 9 seconds. कुछ तो हो रहा है. Think. Let's see. Siddharth, you solved it. You remember the answer. Solved it.
No. I solved it just now.
Okay. ठीक. देख.
That
Let
correct?
others also try. मुझे याद नहीं है रे आंसर. देखना पड़ेगा.
Actually, I
Might
haven't
be
seen this
right.
question before.
चलो अच्छा है. Try others. Anyone confused with the question? Please ask me. Question is clear. Please go ahead. Think. Take a minute. Again, I'm telling you, it is not about getting the answer. I don't care about the answer. You also should not be caring about the answer. Focus on learning. Think like, okay, what is happening? Be more curious. Have fun while solving the question. Don't become like, the entire world ka weight is on you. As if you don't solve this question, someone is going to die or the world will come to an end. Nothing like that. Don't take so much burden. Think about it. What is happening? Be more curious. That is more important. 31/3. Ali, no, that's not the answer. Most of you have that problem. You don't get a question, you think as if the world is coming to an end. Yeah, much better things to do in life. Right? Solving physics and all is just a part of it. But it is important. It is important. That's not the only thing. But do try. Keep working on this. Try. I'll give you 1 more minute. Ekansh, any ideas? Thinking. Think. Aryan, any ideas? (55/3), Anika. Let's see. I actually don't remember the answer. Could be right also. Siddharth got 58/3. 54/3 chance ही नहीं है रे. Or do you meant by 40/3 or 4/3? You goofed up something. Pratyush, I'm asking, find the time interval you hear the sound. I'm not asking when will you hear the sound. Both are different. I know my handwriting is not that great, but for how long did you hear? Matlab, it's a time interval. Lakshika, I think you might be right. Yeah. वही सोचना पड़ेगा एकांश. Sound test continues. Listen, what's happening? I'll tell you. Now, initially, the sound is released at A here. This guy is B. This is C. First, let's see how much time it takes to go from A to B. So from A to B, we are using S is equal to UT plus half AT square. S is 400. U is 0. Acceleration is 2. So 20 seconds. So it takes 20 seconds for the train to go from A to B. That means the sound of the horn is for 20 seconds. For 20 seconds, the horn is, working. Now, the first time when we'll hear the sound, tell me one thing. The sound when it is released at T0, will the observer immediately hear? It will take some time, right? The sound will take time to reach C. So the first time he hears, so at T0, the sound is released. He hears the sound. This distance is actually 500 meters. 300 and 400, na, Pythagoras theorem. This A to C distance is 500 meters. So the first time when he hears the sound, T will be 500 by 300, 5 by 3 seconds. At 5 by 3, he will hear the sound for the first time. Then the last time he will hear the sound is the sound which is released at B. This will be the last sound wave. This red one is the first sound pulse. Because after B, you won't hear the sound, the engine is off. Now understand, it took train 20 seconds to reach B, and then it took another, this distance is how much? 300 meters. Then it took another 1 second for the sound to reach here. So the last sound he will hear, last sound pulse is heard at T is equal to 20 plus 300 by 300. That is 21 seconds. This is the time taken for the train to come from A to B. This is the time for the train from B. This is the time taken for the sound from B to C. Means you heard the first sound at 5 by 3. You heard the last sound at 21 seconds. So the time interval he heard is first sound, last sound minus first sound. So time interval sound is heard is 21 minus 5 by 3. That is 63 minus 5, 58 by 3 seconds.
Sir,
Are
I
you
did
getting
it right, but just I did minus wrong.
So then it is wrong only, you'll get a -1 in the exam. So what is happening here, na, Ekansh? The sound was released at different points, na? The sound was not traveling the same distance initially and finally. Initially, sound traveled how much? 500. Finally, how much it traveled? 300. So the 200 meters ka distance is there. That became shortened. So in the second time, the sound had to travel less distance. So you heard the sound little before. Is this getting the logic, everyone? Because the sound was being released at different points, the sound was traveling different distance. Initially, sound traveled 500, finally traveled 300. So there's a difference of 200 meters per distance, 2 by 3 seconds. That's the difference that you're getting. So even though the siren is on for 20 seconds, you could actually hear it only for this much. Do check this out. It's a good one. Anyone didn't get the process? Any step that you're not clear, please ask. All sure? From B to C, what is the distance traveled, Anika? 300 meters. What is the speed of sound? 300 meters per second. So time taken is what? Distance by speed, no? Right? Sound takes 1 second to go from B to C. All clear with this? Aryan, got this? Ekansh, clear, na? Pratyush, got it? Got your mistake? Anshul? Clear, na, Anshul? I can't see you, Anshul. Do adjust your camera a bit. Saurja, clear? Maika, Dikshita, clear? Anak? Perfect. Next one. Let's see a standard model. This is another standard question. We have a wooden plank. And let's say you fired a bullet. If you fire a bullet with speed u, it comes out with a speed of 19 u by 20. A bullet loses 1 by 20th speed after passing through a wooden plank. Assume constant deceleration. This is a standard one. How many planks are needed to make the speed half? How many planks are needed? First question, let's say to stop the bullet. You want to stop the bullet, so how many planks should you keep? We can just modify it a bit to make the speed half. If you want the bullet ka speed to become u by 2, how many planks you need? Let's get this. So you took one wooden plank and you fired through it and the speed became half. Now, if you take multiple planks and you fire, the question is how many planks you need to stop the bullet and how many planks you need to make the speed of the bullet half. Try. Lakshika, that's right. Ali, try. Ali, focus on the class.
Focusing only, I'm asking. I'm multiplying 1919.
Whom you're asking? You're asking your parents in the house what is 19 into 19. Any other answers? Saurja, you got it right. Pratyush, you're wrong. Ekansh, I think you're right. Lakshika, you got 8 kya? Ekanshu got 6. I'm not sure. One of you is wrong. For the second part. Pratyush 22. No, that is wrong. Anika wrong. Dikshita, you're right for the first part. Get the second part also. Keep going, everyone. Aryan answers. Siddharth, I didn't get the answer this time. Anshul, no answers today. Not well.
No, sir, I'm good.
Good only. Chalo. Maika answers. Let's see. Anika. Ali. First part is right. So, then take a plank here. You're firing with speed u. The speed becomes 19 u by 20. Let the thickness of the plank be d. Now remember, I don't know the d ka value. I'll assume. So I'll apply the equation v square minus u square is 2as. So here the final speed will be 19 u by 20 whole square minus u square is equal to 2at. Now you want to stop the, let's say you kept n planks. This distance becomes nd. So let the speed be u and let the speed be v. So if I apply this equation now, v square minus u square will be 2a and d. Now first problem, you're saying it will stop. So v is equal to 0. So you get minus u square is equal to 2ad into n. So take 2ad ka value from here and dump it in this. You end up with minus u square is equal to 19 square by 20 square minus 1 into u square into n. U square will cancel. N turns out to be approximately 10.24. That is, n should be 11. Means you need 11 planks to stop the bullet. Means you need 10 plus 1/4 of a plank to stop it. So we need 11 planks to stop the bullet. The second part of the question, you just want to make the speed half. So u by 2, substitute there. You end up with u square by 2 minus u square is equal to 2ad into n. Put it in this. You get minus
Four, na? You said
u square by 4 minus 3u square by 4 is equal to 19 square by 20 square minus 1 u square into n. U square goes off. How much is this? 20 square, that is 400 by 39 into 3 by 4 is n. 4s are 100s are n would be 300 by 39. How much is this? Approximately 40 liya to 30 by 4 na 7.5 something. 7.5 something. Therefore, n is equal to 8. You need 8 planks to stop the bullet. Make the speed half. But you need only 11 to stop the bullet. If you get a number like 13.37, you should take the next integer, 14. The meaning of 7.5 is you need 7 planks plus an half plank to stop. So if you just want the speed to become half, if you use 8 planks, it will become more than half, but ठीक है, approximately. You can't put an half plank. Do check this out. So I wrote an equation for 1 plank, I wrote an equation for n planks, and then I substituted v is equal to 0 to stop, and I substituted v is equal to u by 2 for half the speed. Any doubts on this?
What's up, guys? Everything Alpha Pro here, and today we're going to be testing the true durability of iPhones. Can they save your life? In this video, I want to know how many iPhones does it take to stop an AK-74 bullet. Now, this AK-74 Russian heritage, and I'm going to be making my Russian heritage proud today by destroying up to 8 iPhones. I want to see which phone the bullet will stop at. I've got 3 6 Pluses, a couple iPhone 6s, and smaller ones, and an S6 in the very back, just in case. But I don't expect it to get past 4. The bullet, I think, travel at up to 2,900 feet per second. This thing will totally obliterate these guys. So unfortunately, I couldn't afford a $100,000 slow motion camera. I worked with what I had. All right, now here's the moment of truth.
There. So he kept
How many
iPhone. Some are actually one or two of them are clones, and one is a Samsung actually.
iPhones would you have to carry in your pocket in order for them to save your life?
2, 1.
And the answer to that question is 5 iPhones. The bullet pierced the first 4 and landed in the screen of the 5th one, which is also the iPhone 6 clone. I didn't really expect the bullet to make it so far, but it absolutely shredded through them. Now, this is a steel core AK-74 bullet, which also has some light armor piercing capability. Notice how the intensity of the bullet increases as it moves on through the iPhones. And no, not a...
Actually, this is what happens, when the bullet starts passing through, it forms a shockwave in front of it. So as you go through, the hole actually becomes bigger and bigger. So movies mein dikhate hai na, so if someone actually shoots you, right, in the front there'll be a small hole, but behind the hole is bigger.
Single one survived. Number 4. All right, so now that we've determined you'll need to carry around 5 iPhones in order to save your life.
There. So if you're going to battlefield, you just have to carry 5 iPhones to stop the bullets. Or you can buy an armor. That is better.
From a bullet,
iPhones are a
let's go
little
ahead
too
and try and
expensive.
aim at a different portion of the display. 3, 2,
They're shooting at higher height.
1. Now this time, when shooting in the middle, the bullet managed to punch its way through 5 iPhones and land on the 6th. All right, so 1 iPhone actually survived. So, as you guys can see, this iPhone
It is
has
working.
survived. The touchscreen still works where the bullet impacted, but this was the last stop on the bullets hit list, this iPhone 5S.
There. That is how it looks. Practical applications of firing a bullet on a wooden plank. You can shoot iPhones. Clear. Let's see. Next one. So we have a vehicle which is going with 36 kilometers per hour. And when brakes are applied, it stops in 20 meters. A vehicle needs a stopping distance . meters when traveling at 36 kilometers per hour. Means if you're traveling with the speed of 36 kilometers per hour and apply brakes, for the vehicle to come to rest completely, it takes around 20 meters. And this is true for all the objects, Did you ever observe this thing? Movies may they show, right? The hero is running on the railway track and the train is coming from the opposite direction. So this guy just starts shouting and waving the flag and everything. And for some reason, right, the train stops. Whereas in reality, the story is the reverse actually. The train will hit the hero and take him to the next station. The trains don't stop. The reason, number one reason, first thing, see, if you suddenly enter in front of a vehicle, right, the problem is, the vehicle has some inertia. It takes time for the driver to react. And second thing, it takes a lot of distance to stop. For example, if you take, India ka trains now, when a fully loaded train, passenger train is going at full speed, that is around 110, 120 kilometers per hour, it would require around almost half kilometer distance to stop. Half kilometer. The problem is what you can stop even earlier, but then you have to apply emergency brakes. Now, the problem is when you apply emergency brakes, the engine will slow down a lot, but the compartment behind, right, will get pushed. The compartment get pushed. There is a chance the compartments will derail. So this is what will happen. This compartment is pushing so hard, it will become like this. So in order to save that one person, you might actually kill more people in the train. So what the driver does is he will try to slow the train at a permissible speed. If the train stops, the fine. Unfortunately, if the hero is still standing in front of the train, he will go with the train, free ticket. So, it is not like only in movies where the train stops like that. Now, a bullet train, this Japan with the bullet trains they have a speed of 300 kilometers per hour. They require a stopping distance of around 3 kilometers to stop. 3 to 6 kilometers. Meaning they'll start applying brakes at a distance of 6 kilometers even before stopping. So that is the reason if you have a bullet train, right, you need to have stations pretty far. So in France, now these people tested a train called TGV. It's the world's fastest train, which had a speed of 650 kilometers per hour. Just for testing purpose, just to break the Guinness World Record, it reached a speed of 600 plus kilometers per hour. TGV, France TGV, you can search it out. This thing requires a stopping distance of 20 kilometers. You want to stop the train, you have to start applying brakes on 20 kilometers. There, the faster you go, the more stopping distance you will need. So our question is, now we got another vehicle, which is going with 72 kilometers per hour. Another vehicle goes with 72 kilometers per hour with half of the deceleration. For some reason, the brakes are not working properly. With half of the deceleration, let's call this A and B. Half of the deceleration of A. Find the stopping distance. So if this vehicle has only half of the braking power of A, but the speed is doubled, find the stopping distance. How much distance, if you apply the brakes, and how much distance will it stop? Okay. Try everyone. It's an easy one, but standard problem. Let's see. Right, I can. Try everyone. I'll give you a minute.
I said my answer.
Let's see. Think about it. See, the vehicle is going with you. Let the deceleration be A. Eventually, right, the vehicle stops. So if I use the equation v square minus u square is 2as, v is 0, u square is 2as. So here this is we get s is proportional to u square by a. This is your formula there. S is the stopping distance. So if you double the speed, it becomes 4 times. If you make the acceleration up, it becomes half there. The stopping distance is proportional to u square by a. So SA by SB will be UA square by acceleration of A, UB square by acceleration of B. So SA is 20 meters. SB, UA is 36 kilometers per hour. I can convert it in meters per second, but that is fine. That would be 10 square. Acceleration is A. This guy has become 20 square and acceleration has become half. A by 2, so 2 will come up here. A will cancel. We end up with SB is equal to that is 8 into 20, 160 meters. Check. Just a matter of taking ratio, right, Saurja? Pratyush, Siddharth, you're right. Ekansh, Lakshika, all of you got it right. Easy? Yeah, so there are two variables that u square and a. I'm changing both of them. Next one, everyone. Any doubts on this? Ali got this. Anay?
Sir,
Haan, Dikshita, bolo.
sir,
What happened?
I got this answer, but I didn't use this ratio. Like I just normally did.
Yeah, you can actually calculate. You can find for each one separately. Actually, end of the day, you did the same thing, but I gave you a more shortcut, nothing much.
Okay.
You're right. You're right. It is just maybe a little longer.
Okay.
What you did was you wrote two equations, no? And then you equated that RHS or whatever. You will get the same thing. Yeah. All clear with this? Next one. We have a wall here. And we have a vehicle here, a car or something. Starting from rest has a constant acceleration. This is t is equal to 0. The distance between the car and the vehicle is d. Okay. This is the top view. Okay. You're seeing this from the drone or something. This is the top view. You're seeing this from the top. So a car starts parallel to the wall. Right, at a distance d, as shown. So at t is equal to 0, the driver sounds the horn. Once only, it's not like a siren. He just presses the horns once, like he sounds the horn. And at the same time, he accelerates also. Sounds the horn. And accelerates. With it. So the question is, after what time, and let's say the speed of sound is c. After what time does he hear an echo? I hope everyone knows what's an echo, right? The sound hits the wall and comes back to you. That's called an echo. After what time does he hear an echo? Let's get this. Now, just to tell you what is happening, the sound which will go like this, it'll hit the wall and come back. Will the driver be at the same place? The driver has already gone ahead now.
Yes.
Try. The numbers are bad. It's all equations only. Just get me the equation. That is sufficient. Try 2-3 minutes. So he sounds the horn once, only once. One sound he makes, and the vehicle also starts at the same time. After what time does he hear an echo? Now think, how is he hearing the echo? Where is the sound coming from? Now you have to think about all that. That's one thing. Don't worry about getting the answer. Take time, think about it for 2 minutes, and then try to solve. You're still not getting, I'm there. I'll teach you anyways. Try. Anyone confused with anything, please ask. Just give it a try. I'll just get some water and come. You got a quadratic? No, I can't. You'll get a biquadratic. You'll get a power 4K equation. You won't get a quadratic. Chalo, I'll tell you what is happening. Then you try to solve. I'll give you 1 more minute. How the hell is he hearing an echo? What's happening now? After time t, this guy has gone forward. Now tell me one thing. When the sound is released, do you think sound only goes to one place? Doesn't sound go to every place on the wall? Isn't it? Sound travels in 3 dimensions, isn't it? So sound goes to every point on the wall. That means in the time this person has traveled from here to here. Let's say this is where he hears the echo. Let's say after time t hears an echo. The sound has traveled from here and it bounced off the wall. Are you getting this? So the sound which went to this position, that reached him, and that's why you could hear an echo. Are you clear? This was the path of the sound. So there is some sound wave which went at an angle and hit the wall. Basically, law of reflection. This angle and this angle will be equal. This distance is d. This total distance is half at square. Acceleration, na? So this distance will be 1/4 at square. So if I just name these points here, A, B, and C. So this length AB will be root over d square plus 1/4 a square, 1/4 a square, 1/4 a t square ka whole square. So the total distance traveled by the sound will be AB plus BC, which is nothing but double 2 times root over d square plus a square t power 4/16. And what is the time taken for the sound to reach? So time taken for sound to go from A, B, C will be distance by time. So distance will be root over t square, a square, t power 4/16 by speed of sound is c is nothing but t only, isn't it? The time taken for the vehicle to go from A to C is equal to the time taken for the sound to go from ABC. Yeah, you're done. Square it on both sides. You end up with 4 d square plus a square t power 4/4 is equal to c square t square. This is a biquadratic equation. A square t power 4/4 minus c square t square plus 4d square is equal to 0.
Sir, I simplified this by making all denominators same and then cutting it up.
How did you do that? Let's see.
Well, I got the same, but then that 4 below, I took it
Then
to this thing.
ठीक है ना, a square t power 4 minus, I'll just show you the previous page, minus c square t square plus 4d square is 0. So here you take the t square as a, so put t square is equal to x types. So your quadratic equation becomes a square by 4x square minus c square x plus 4d square. There, this is how you make a biquadratic, matlab power 4 to power 2. We get x is equal to c square plus minus root over b square. That will be c power 4 minus 4a square d square by a square by 2. Clear? But x is what? T square. X is nothing but t square. So we get t is equal to root over 2 c square plus or minus root over c power 4 minus. Did you observe one thing? I got 2 answers. Actually, the person will hear the echo 2 times. We didn't realize that. That means there is one more sound wave which must be going like this and which he can hear. This is the best part. When you solve something with variables, you can figure out more data. So we thought he is hearing the echo only once, but there are actually 2 sound waves he can hear. He will hear the sound twice. Please look at this equation once, what I did. So in time t, the car will travel half at square. The sound will travel from A to B and B to C at an angle theta. So I found the total distance traveled by the sound and divided by the speed of the sound. I got the time. And that time should be the same time as the time taken for vehicle to go from A to C. I got an equation, power 4. I just wrote t square as x and I solved the equation. Any doubts on this page? There is something more interesting I can ask you in this thing. Find the condition if the man never hears the echo. There's a question like that also. Tell me what should happen for that. What is the condition? If the man should not hear an echo, what should happen? If delta discriminant b square minus 4ac becomes less than 0 means what? Roots are imaginary. Means there will be no time for which he will hear an echo. That is, he can't hear an echo. That would be a good question. So that means c power 4 minus 4a square d square should be less than 0. Then you get c should be less than root 2 ad. If the speed of sound is less than root 2 ad, you will never hear an echo. Check. Please check this out. Ask me if you're confused. Any step you're not clear. So the person can hear up to 2 echoes. That's the best thing about doing with variables. You can get more data from it. Clear with this, Lakshika? Got the same? Dikshita, clear, no? Mayuka? Anshul? Siddharth? Pratyush, clear, no? Anay? Aryan? Sharja, you're clear, right? I think you got disconnected for a moment. Can I go ahead, Ali? Perfect. Next thing. So let's say we have a vehicle here, A, which is going with an acceleration A is equal to 2 meter per second square. Initially at rest. We have another vehicle here, B, whose acceleration is A is equal to T. It's not constant. This is also starting from rest. And the distance between them is, let's say, 1001 kilometer. Find the position where they collide. Get this. So there we brought a non-uniform acceleration into this. We have one vehicle going with 2 meter per second square, one vehicle going with A is equal to T. T is time. As time passes, acceleration becomes more and more. Find the position where they collide. Just get me the equation and leave it. Just get the equation. No need to simplify. I don't think we'll be able to solve this. I mean, you can solve, but you'll get a cubic equation, I guess. Just get me the equation. I'm just interested in the physics part. Max part we can handle later. Two vehicles going opposite to each other. Initial velocity is 0, acceleration is 2, and A is equal to T. Find the position where they collide. Siddharth. That looks right. Anika. T square by 2, 1 minus T by.
I actually said that that's actually wrong. Matlab, I forgot to multiply the 1000 into the denominator. Once again.
और T cube तो आएगा मुझे इतना याद है. I don't remember the full thing. Let's see.
Once again, I'll change my answer. I'll send you the file.
Now, how to do this thing? First of all, acceleration is a is equal to t, you can't use the regular equations. Don't do this. I have seen people doing this. S is equal to ut plus half at square. They take this a and put it here. We get ut plus half t cube. This is a blunder. Don't do this. Why? You can't use this equation. A is not constant. You can't use the equation S is equal to ut plus half at square when A is not constant. So you don't do this way. This is wrong. Be careful. Then how do you do this thing? A is equal to t. Acceleration is dv by dt is equal to t. Send that thing that side, t dt. Integrate 0 to v, 0 to t. We get v is equal to t square by 2. Once you get v again, then you can write it as dx by dt is equal to t square by 2. Send dt that side. We get t square dt by 2. Integrate again 0 to t and 0 to x. We get x is equal to t cube by 6. This is the distance traveled by the vehicle as a function of time t. So our vehicle A is coming from here with A is equal to 2 meters per second square. And this guy B is traveling from here. Let them collide somewhere here. The distance x means how much should A travel? 1000 minus x. So for A, if I write the equation, A guy acceleration is constant. So S is equal to ut plus half at square. S is 1000 minus x. U is 0. Acceleration is 2. So t square. This is equation 1. For B, x is t cube by 6. Just now we derived it. So take this thing and put it there. You end up with 1000 minus t cube by 6 is equal to t square. So we get t cube by 6 plus t square minus 1000 is equal to 0. From here, you'll get the time. Let's not worry about how to solve the quadratic. The cubic. Max part is pain, but if you got till here, your physics part is clear. How to solve this, that's a different headache. Let's not get into that. I'm more interested in how you approach the problem. Do check this out.
Sir, I have a doubt.
हाँ दीक्षिता बोलो ना.
I took the same like x and 1000 minus x, sir, but like I just reversed it. Like the distance traveled by A is x and B is 1000
Right. Right.
like we can use.
Then this 1000 minus x should be t cube by 6.
Yeah, but I did like v is equal to u plus at, and I found v in terms of t, so everything is
This is for whom? You're talking about A or B?
for A.
Okay, fine. Then
So I got v is equal to 2t, and then v square minus u square equals 2a's, and substitute t equals root x.
that won't help you, right? What is the use of that? You're finding only for A, na? What is B doing during this time?
Yeah, I can solve for B also parallelly, but the thing is that I got in terms of A the answer.
No, because see, you took the same two equations. Na? You took v is equal to u plus at. You took v square is equal to u square, this thing, right?
Yeah.
Both are actually belong to the same point, na? So you didn't get anything new.
Oh, okay.
You didn't get anything new. If you actually take this v and put it here, you will actually get s is equal to ut plus half at square.
Fail.
Got it? You didn't do anything new. You took the two equations, you generated the third equation. That should not give you anything, ideally. Yeah. Can we do it without integration? Like for each nth second, we consider each distance, right? Now, Ekank, you know what you're assuming? For that 0 to 1 second, acceleration is constant, isn't it? Acceleration is changing every instant, na? When time is 0.1, acceleration kitna tha? 0.1. But in your example, you assumed how much? 1 meter per second square. That is wrong. Dikshita, are you clear what happened, right?
Yes, sir, I understand.
Sure. No, if you're still confused, let me know. End of the class, we can discuss. Aryan, clear with this? Anyone else? Any doubt on this thing? Ali, clear? Anay? What happened, Ali? You are happy? No, you should be happy, but any particular
I
reason?
was saying what Siddharth was doing.
Siddharth is dancing actually. After every problem gets over, he stands up, he dances like a tiger, and then he comes back again. And
No,
then,
sir. Actually, I had something to talk to with my parents. My grandpa's in the hospital, so he
okay.
just got back today. He was discharged. That's
Then
it.
it is fine. Even I said that only. Arey, Siddharth must be having something important. Ali is only saying, sir, he dances like tiger and all. He's spreading rumors.
So I am not spreading rumors. You are spreading rumors about me.
I said, when you think about it, not a bad idea, right? Every time I give a question, you get an answer, you stand up and you dance and you get back again. Like maybe that refreshes you. One of my friend, not dancing, but he used to sing songs during exams. And the teacher told him multiple times, especially chemistry teacher used to scold him. Don't do that, don't listen to songs while studying. Unfortunately, it happened in the exam. This guy forgot something inorganic. He was trying to remember. All he can remember is a song. So happens. The next thing, motion in a vertical line. We'll just finish off with the theory. We'll do more problems in the next class. Now, till now, we did all the problems when the particles are going horizontally. The gravity didn't affect the problem. So motion in a vertical line. Every body on the Earth's surface is attracted by the Earth. Generating an acceleration, generating a constant acceleration. So every body on the Earth's surface has a constant acceleration. Which we take it as, we call this acceleration due to gravity. We use the symbol small g, which is 9.81 meter per second square. For convenience, we take g is equal to 10. You can examine what happens, right? You can see the options. Options are 19.6, 39.2. He has taken 9.8. Numbers are round figures. Generally, g is 10. If they don't mention anything, take g as 10 and solve. It works out. Now, the important thing here, this acceleration is independent of the mass. Means you take an elephant, you throw, or you take a rat and throw, you take a coin, ball, doesn't matter. This is independent of mass. But in real life, what happens, right? Due to air resistance, we don't see this. Due to air resistance, we don't observe this in real life. But if you can actually create a condition where it is complete vacuum, you will actually see both will fall with the same acceleration.
This is NASA's space power facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it's kind of got a, and that meant
This thing, right, what he's showing is actually a nuclear silo. During the Cold War, right, US used to use this for launching missiles and stuff. After the Cold War got over, they converted this into a NASA facility where they test, spaceships in vacuum. So before sending a space shuttle, anything into outer space, you want to see how does it behave in vacuum. So they keep the shuttle in this and they remove all the air. So this guy got into that NASA thing and
they built it out of aluminium to make outer concrete skin, which is part radiation shielding and part an external pressure vessel. So this thing can take. Galileo's experiment was.
so standard thing. So air is there. He took a bowling ball and he took some feathers, and we can expect what will happen when you drop them. This is what happens when you have air. feathers will come aram se, and the ball just
Now, in
falls
this
down pretty
case,
straight.
the feathers fell to the ground at a slower rate than the bowling ball because of air resistance.
So generally, right, lighter objects get more affected by air resistance. Same thing, if you throw a feather, it takes more time, heavier objects just fall.
So, in order to see the true nature of gravity, we have to remove the air. It takes 3 hours to pump out the 800,000 cubic feet of air from the chamber.
Okay, we dropped 2 millitorr in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCB 30-1, pressure set point at 240 psi. We are go for drop.
10.
Now it is perfect vacuum inside.
7, 6, 5, 4. Cameras on. 2, 1. Release.
Observe, they're always side by side. They reach at the same time.
Exactly. They came down exactly the same. Wow.
See, they're always side by side. If there's no air resistance, this is what I was saying. Independent of mass, it doesn't matter. Simple reason. F is equal to ma, F is mg, m and m will always cancel.
Look at how they hit right there.
Exactly.
Back on the side.
Exactly the same.
Feathers don't move, nothing.
Look at that. That's just brilliant. Isaac Newton would say.
So there. So we are just not bluffing. What I said is true. It is independent of mass. So do remember this. Yeah. Now, next thing. When you keep saying up and down, what is up and what is down exactly? So when you say up,
With respect to Earth,
so do you mean to say people on the North Pole are like this? So in the South Pole, people walk with the heads, yeah? And equator may people crawl. So exactly what is up and down then? So when you say up and down here on Earth, it is towards the center of the Earth, isn't it? So when you say down, you're saying towards the center of the Earth. So when you say up and down, that's what it means. So simply the direction of the net force is called as down, and this is up. Important concept. You should actually know the meaning of up and down. It is not up and down we show, but that goes completely wrong. It all depends on, how is the direction of the net force. So whenever you say vertically downward, so someone asks you what is up and down, this is the definition you give. When you say vertically down, it is the direction of the net force. Who is Manoj? Right. So in this case, on Earth, it is toward the center of the Earth. Now, whenever we study this motion in a vertical direction, right, we study under certain assumptions. The first one, we neglect air resistance. It'll make our study more easy. We have a separate chapter called viscosity. There we will study how air resistance affects. Second, we neglect the variation of gravity. If you go to very high heights, the gravity actually starts changing. So we are assuming you're not throwing particles that high. 1, 3, 4, 5 kilometers, 10 kilometers is fine. Anything more than it goes 50, 60 kilometers, it starts actually affecting. The third one, we neglect the Earth ka rotation and curvature of the Earth. Earth actually bends. Means we are assuming Earth is a flat surface and solve. So these are the three important conditions you have. So when we say the curvature of the Earth, you know what happens exactly on the Earth? If you travel 8 kilometers, for every 8 kilometers, the Earth actually goes down by 5 meters. The Earth is actually bending down. That means if you take two buildings at a distance of 8 kilometers, this is how it looks. So the difference between these two buildings is 5 meters, even though both the buildings are same height. Every 8 kilometers, Earth bends by 5 meters. Did you guys ever think about this? Why don't you hear, the Pune ka FM channel in Mumbai? Or same thing, why don't you hear the, think about this. Electromagnetic signals or the radio waves, they can travel very far, right? When you send a satellite into the, moon or something, you get a signal from moon to Earth that's almost 384,000 kilometers. But you can't hear a FM channel in Hyderabad in Mumbai or even Pune ka thing in Mumbai. Any idea why? Your phone will think, "Arey, ye Pune ka channel hai, let's not hear it." I mean, phones are not that racist, so they don't care actually. They get all signals. Something happens actually. You know what? The Earth ka curvature. Yep, right, Anika. Think about it. If you have an antenna like this, how will the signals go? In straight lines. You get tangents. That means if you have a city here, they won't know there's a signal going on. That's the problem. Same thing happens even in your city also. The Earth bends within the city also, right? So you need a tower for every certain distance. That is the reason they like to put the tower as high as possible. You can cover more area. So this is the problem actually. And actually the radius of curvature of the Earth, right, is actually what saved the world from nuclear arms race. During 1950s and 60s, right, during Cold War, US and Russia were both going mad and making more and more powerful nuclear bombs. Around by 1960s, right, these people had, we call them thermonuclear warheads. Oppenheimer movie bhi aaya na abhi. So think about that. By 1960s, now these people had bombs which are 2 lakh times more powerful than Hiroshima and Nagasaki ka bomb. Meaning both were just going mad. US had enough weapons to destroy the Earth 8 times. I said, yaar, matlab ye kya pagal hote hain? Why the hell you want to destroy the Earth 8 times? And you know what stopped them from making more powerful bombs? They realized it is pointless to make powerful bombs because if you actually blast a bomb, what happens? The radiation will spread how? In a straight line. So the radiation actually go into the outer space. The blast will go into outer space. That means if you blast a bomb in Mumbai, the blast will go, over the city of Pune. So Pune will not get affected. So what is the point of making a more powerful bomb, right? The point of making a more powerful bomb, you want to destroy more area. Meaning, if you actually take a nuclear bomb, it had enough power to maybe wipe out half of Maharashtra. But because of the curvature of the Earth, most of the blast will actually go into the outer space. So then Russians and US people decided there's no point in making powerful bombs. Instead of that, let's work on something called multiple launch vehicle. You launch a missile into the air, it splits into 7 different and falls on 7 different cities. When it comes to destroying stuff, no, bloody we humans are so innovative. We figure out stuff and we invent things. Yeah, ICBMs and all that. Creative चीज के लिए ideas नहीं आते हैं, but to destroy तो we use all our resources and knowledge. Anyways, that is one part of the story there. Okay.
But in that first case, which you were telling, the bomb, all the radiation will go into outer space. So basically, more powerful weapons are just wasting energy for no reason.
Yeah, no, that's the point. No, you make a more powerful bomb, the energy is just going outside. You made a powerful bomb thinking what? I will drop one in Hyderabad. It will blast away Hyderabad, Mumbai, and that's it, Andhra complete. But that doesn't happen. So yeah, more powerful bombs, that's the problem. Clear? So, and not only this thing, and Earth ka rotation also matters. Did you ever think about this thing? Mumbai, you don't get cyclones much. You get once in a while, but Mumbai, you don't get cyclones. Chennai, you get a lot of cyclones. My hometown, right, Visakhapatnam, I am also from East Coast. If you see, right, and the entire East Coast, the Bay of Bengal side, most of the water we get is from cyclones. We don't get monsoons there, like Mumbai side. Not much. And you don't get cyclones here. You get pretty rare cyclones in Bay of Arabian Sea. You know why? You studied this in school geography. How does the Earth rotate? What do you see first? You see the sun rising in the east, right? But you know, sun is not moving. That means the Earth is going from west to east. Earth rotates from west to east. You're getting it? We are going towards the Japan. So whenever you get a cyclone, the cyclone is there only. But what is happening? We are going towards it, right? So whenever you get a cyclone in Bay of Bengal, we are going towards the cyclone. So it looks like as if cyclones are coming and hitting the coast. Any cyclone that forms in Arabian Sea will not come to Mumbai. It will go off to Dubai side. The cyclones always drift towards west. This is what we call as Coriolis force in geography, if you have studied. Something of that sort. So their Earth rotation does matter. It does affect a lot. Okay, that's one part of the story. So we will wrap up with this, a little intro here. So next class when we meet, we are going to do what are the equations in a vertical motion, and then we'll see the vertical part in the next class. Okay, so make sure to revise this stuff. We have done almost like 18 problems, right? And hope Anika got the booklets. Right, Ali, did you get the booklets?
Yes, sir. I have doubts.
Right. Okay. So those are doubts. Please stay back. You have to send me the snapshots, Ali. You have to send me the photographs of the doubts in WhatsApp.
Sir, from question paper only, na?
You have to send me.
Achha.
Which paper? Vectors ka paper? Ruko then dekh.